Hi everyone, this is our look at aromatic compounds. Aromatic compounds are classified as those that contain a benzene ring. Benzene is a 6-carbon structure that also happens to have 3 double bonds. It might look like this, a hexagon with 3 double bonds specifically shown in it. However, typically we show it as a hexagon with a ring with a circle in the middle. These double bonds over here, they're actually resonating around the structure, so typically benzene is actually shown with this circle in the middle. It's a really big deal that this is not cyclohexene. It's not. It's its own unique thing. Benzene, it's aromatic. This structure has the formula C6H6. That's the chemical formula for benzene. However, once the benzene is attached to something else, if there's a branch on there or 2 branches, we have to really be careful about how we're counting up the carbons and hydrogens. It's always going to have 6 carbons because it's always going to have this hexagonal shape with 6 corners, 6 carbons. But we really do need to be careful counting the hydrogens. Remember that carbon can only have 4 bonds. So if each of these corners already has 3 bonds, so there would be 1 hydrogen on each corner. But if it's attached to one thing, it's C6H5. If it has 2 branches on it, it would be C6H4. That's especially a thing to be very conscious of as we get deeper into the unit. The naming rules for benzene, the naming rules for aromatic compounds, they come in these 2 big situations. It does make a difference if the benzene is acting like the longest chain or not. If the benzene is acting like the longest chain, we see it and we say benzene. The names always end in benzene. Branches, we're going to follow the exact same rules as we did for cycloalkanes. Just a reminder that methyl, ethyl, propyl, the branches get named in our usual way. If we have 2 of the same branch, we say di. So 2 methyls we would call dimethyl, 2 ethyls diethyl. If we have different kinds of branches, we name them alphabetically. If there is only 1 branch, we are not going to assign that branch a digit. If there's multiple branches, we'll start numbering at a branch and go clockwise or counterclockwise so that the numbers that we arrive at are as small as possible. A second big scenario is the benzene might be acting as a branch. So if the benzene is attached to a carbon chain, say an alkane, an alkene, even an alkyne, of 7 carbons or longer. Benzene has 6 carbons, so if it's attached with something with 7 carbons, then the benzene is shorter and it starts to act like a branch. If it's acting like a branch, then we treat it that normal way. It's a branch that starts with P. So our normal rules for an alkane or an alkene or an alkyne would apply, only we would see benzene on it and we would call it phenol when it's acting like a branch. Chemicals that have benzene in them are classified as aromatic. It's a really important distinction for us in our course. If we see benzene, whether it's acting like the longest chain or if it's acting like a branch, if we see benzene at all, a hexagon with 3 double bonds or a hexagon with a circle in it, if we see benzene, we classify the chemical as aromatic. If we do not see benzene, it is not aromatic. Look for that in an upcoming video as well. And I hope this helps.